Hi there, Mr. Sutton here, bringing you the Algebra 2 3-5 Part 2 homework solutions on solving nonlinear systems of equations. In this one, we focus largely on the elimination method, although substitution is still an option. So now we have all the options. For this first system of nonlinear equations, deciding if I want to use substitution or elimination, I notice here that if I were to add these together, that would immediately cancel out these y's. So I'm thinking elimination works out pretty well. I don't have any variables isolated, so substitution would take a little more work on this one. So let me label my equations then, E1 and E2, and let's just add these together as they are. So I've got, let's see here, the y's are going to cancel. That was why I did this. And then adding up whatever's left over on each side, this 2x squared has nothing to get added with, so it just stays the way it is. Negative 3x plus negative x is negative 4x. And then on the other side we have negative 5 and 5 giving us 0. Well, this one is actually going to be pretty quick to factor. I just have to take out a common factor here of 2x. That leaves me with x minus 2. All of that equals 0. And now let me go ahead and set each of these factors equal to 0. If 2x equals 0, that means that x equals 0. And I can plug that back in to get a y value that goes with it. So between the two equations, I think the second equation is a little bit easier to work with. So we can write negative 0 plus y equals 5, which just means y equals 5. So 0, 5 is one of my points of intersection, one of my solutions. Now the other solution is going to be what I get when I set x minus 2 equal to 0. That's going to be x equals 2 for that one. And then plugging it back in, I'm again going to use the negative x plus y equation. So we have negative 2 plus y equals 5. Adding 2 to the other side, we get y equals 7. So then 2, 7 is my other solution. For this problem, deciding between substitution or elimination is a little bit trickier. We have y completely isolated in two equations, so this actually would be a pretty good one for substitution, but I'm going to show you elimination because it's almost as fast. So if I add these together the way they are, nothing's going to cancel, but if I multiply one of these by negative 1, then I could be in business. So let me label each of these, E1 and E2. And I'm going to multiply the first equation by negative 1 and then add that to the second equation. So this will be a negative y equals positive x squared plus 6x plus 10. And the second equation I'll just rewrite as is. So adding those together, those y's cancel. That leaves me with 0 actually on the left side. And then we have 4x squared plus 6 and 18 gives me 24x, plus 10 and 22 gives me 32. Before I go quadratic formula, let me see if I can divide this by a common factor. It looks like these are all divisible by 4. So dividing everything by 4, I'm going to have 0 equals x squared plus 6x plus 8. And then that looks very factorable, just two things that multiply to 8 and add up to 6. That would be 2 and 4. So x plus 2 and x plus 4. So setting each of these equal to 0 and solving, for my first parentheses I've got negative 2 zeros that out. And let me just plug that back in to get a y value before I forget to do that. Now between the two equations, these both look kind of equally nasty. So I'm just going to plug this into the first equation. So we have negative 2 squared minus 6 times negative 2 minus 10. This is negative 4 plus 12 is going to give me 8 minus 10 is going to give me negative 2. So negative 2 comma negative 2 is our answer for that one. That's kind of cute. Now the other branch here, if I set x plus 4 equal to 0 and solve that, we're going to have x equals negative 4. Plugging that into this negative x squared equation, let's see what comes out of that. So this is going to be negative 16 plus 24. That's going to be positive 8. 8 minus 10 is going to give me negative 2 again. Well, that's interesting. So we have negative 4 comma negative 2 as well. So those are our two solutions. For this problem, I'm thinking substitution or elimination would probably take about the same amount of time. Since I noticed that I have a positive and a negative y, if I just add these together, those are going to cancel. I'm just going to go with elimination on this, but either one would work. So let me label these E1 and E2, and I'm just going to add them together as they are, no changes needed. So that cancels out the y's here as planned. That leaves me with 0 on one side. And then on the other side, we have x squared plus 2x squared, giving me 3x squared. And then negative and positive 1, that also cancels out. So now, getting x squared by itself, if we divide by 3, that'll give us x squared equals 0. And then if I square root both sides, I get x equals 0. I could write plus or minus 0, but that's kind of silly because those are the same thing, or plus or minus the square root of 0. So this is our only x value. Plugging that back in, the first equation looks a little easier to deal with. So 0 squared minus 1 gives me negative 1 for the y value. So then 0 comma negative 1 is that answer. For this last problem, we're used to using elimination on everything on this homework set, but sometimes it just doesn't really work. This one, we don't have any of the same kinds of terms at all. We've got squared x's, squared y's, and non-squared ones. Now, we could force the situation if we were to square both sides of this bottom equation. That would give us a y squared, but that's a lot of work. This one, it's going to be much faster just to substitute this negative 3x plus 10 for the y in that first equation. I will need to expand that, though. So I'll have x squared plus this squared is going to be 9x squared. And then I multiply these together and double it for the middle term. So negative 30x doubled gives me negative 60x. And then we have squaring the last thing, that's going to be plus 100, and all that still equals 10. So cleaning things a little bit up a little bit and moving them over to the left side, x squared and 9x squared is 10x squared. Negative 60x can stay how and where it is. And then we have 100 minus 10 giving us 90. All right, well, these are all divisible by 10, so that's going to be x squared minus 6x plus 9 equals 0. This looks like one of those perfect square trinomials, so let me try factoring by square rooting. Square root of x squared is x, square root of 9 is 3. Middle term is negative, so if this works, it would be x minus 3 squared. And if I double these, and multiply them together, so negative 3x doubled does give me negative 6x, so this is the correct factorization. Setting x minus 3 equal to 0, we have x equals positive 3. And then I'm just going to plug that back into this y equals negative 3x plus 10 equation. That one's a little bit easier to work with. So this is going to be negative 9 plus 10, or 1. So then 3 comma 1 is our final answer on this one.